So, seagull flies horizontally over the ocean at constant speed. Small fish in his mouth actually go to the fish, and after this, letting the fish, it lands in the ocean. Ah! So right away... Wait, wait. Can I go? Okay. So right away, my first thought, is the fish is a projectile. Fish is a projectile. Therefore, the vertical acceleration is 9.80 meters per second now. And the horizontal acceleration is 0. Right away when I see something's a projectile, I should realize those two facts about it. And looking at it, before reaching the ocean, what's the horizontal component of the fish velocity? Okay, so they asked about horizontal velocity. Just before reaching the ocean, the vertical component of the fish's velocity. The initial or decrease. Okay, so we'll deal with all that afterwards. I know that all projectiles accelerate downwards at 9.80 meters per second on the planet Earth. And I'm assuming it's the only planet I know that has birds and fish. I'm assuming it's taking place on the planet Earth. We'll get into why planet Earth later in the term. Let's see. Probably think about, that's kind of a generic fact, so I should think about some specific facts to this problem, so that I understand it. If the seagull's flying horizontally, when it lets go of the fish, what does that tell me about the initial velocity of the fish? It's the same as the bird, so it's horizontal, right? So the initial velocity is only horizontal. The initial velocity is only horizontal. So it'd be 0 vertically. You can even put that in here. 0 vertically. So I'm going to draw a little picture. You don't have to. But here's my little fish. And its initial velocity is in that direction. And it's going to fall down. It'll hit the happy little ocean. That's not bad. Now, its path being curved tells me that it's accelerating. Because if it was traveling at a constant rate, it would be moving in a straight line. But it's accelerating, and I know that because its path is curved. All right, does that make sense? Yeah? I mean, we could get more specific. It's parabolic because it's only accelerating vertically. If it was accelerating in both, it would be circular. But we don't need to get that detailed. We just need to know that it's curved, therefore it's curved because the fish is accelerating. So the first thing I'm going to do, let's label some things here. Let's see what else I know. I know that initial velocity is 3.20. So I'm going to divide my paper here into vertical and horizontal. So that velocity horizontal, they tell me is 3.20 for me. 20 meters per second. I know my acceleration here is 0. What's that? It'd be the one labeled meter called, it says the horizontal velocity and it's labeled in meters per second. I think it's the first one. I'll flip back in a second and confirm that. Which way do you guys want to call positive up? Let's call what negative? So you want to call up as positive. Would you like to call it to the right or to the left as positive? Where do you want to, what height do you want to call this where the fish is released? 0? So that means the ocean's going to be at, what, negative H? Is that okay? Horizontally, where do you want to call the point the fish is released? 0? And then we'll call this point over here where it lands. Do they tell us anything about that? Yeah, they said that's time though. We'll just call it, how about D? And, okay, so I know that this is negative 9.80 meters per second. V initial, I know on the vertical side. I said in my Y that that was 0 meters per second. I don't know what my V final is. Oh, I know that my D naught over here on my vertical side is 0 meters. I just wrote that. And that its final vertical height is negative H. Let's see, over here on my horizontal side, I know my D naught is 0 meters, and my D final is D. Any other facts I know? Oh, I know my time, don't I? That crosses over. That's the thing that's on both sides. The time. And it tells me, in this case, my time is 2.5 seconds. All right? So those are all the things it tells me. Those are all my facts that I have here. And let's see. He wants to know the horizontal component of the fish's velocity. Now, let's see. So we know that horizontally the fish starts at 3.2 meters a second. It's not accelerating. So what's its velocity going to end up being? 3.2 meters a second, because it's not changing. Acceleration tells us how the rate something changes that. So this better be 3.20, or I'm losing my mind. Yay! So that means I can start on the vertical side here. You want to know the velocity of the fish just before it hits the water. And on the vertical side, it is accelerating. I want to know the V final. I know the V initial. I know acceleration. I know the time. So I'm going to pick to use V final equals V initial plus AT from my equation possibilities. And I know, let's see, go back up there. So V final equals, well, V initial is 0, isn't it? So I can just get rid of that term. A, which is negative 9.80 meters per second, times my time, which is 2.50 seconds. I get a V final negative, oh, that's good because it's down, right? And it makes sense that the fish is falling down. I get negative 24.5 meters per second. Let's see if it indicates the direction with the sine or angle, so it does want the negative. So let's see if I get it right. Negative 24.5. See. Yay! Now we gotta deal with C. If the seagull's initial speed were decreased, which of the following regarding the fish's velocity upon reaching the ocean would be true? So let's look. If that 3.2 was different, is it going to affect the vertical? Does it affect the vertical velocity at all? Does the horizontal affect the vertical? No. Does the horizontal affect the amount of time? Not in this case. Remember the cannon. How long, no matter how much we fired it, it still took the same amount of time to get down there. Unless we missed the earth. Right? Yeah. So, let's see. The horizontal component of the pitch velocity would decrease. That's true because it says decrease. The horizontal component of the pitch velocity would increase. No, I say decrease. The horizontal component of the pitch velocity would stay the same. No, I said decrease. The velocity, the vertical, we said it doesn't affect it, so of course that's going to stay the same. And let's see if I got it. Yay! Number 6. Tennis player serves tennis ball moving horizontally. Oh, this is really similar to the last one, right? The ball has traveled the horizontal distance of this. It has dropped this from its original height when it left the racket. What is the initial speed of the tennis ball? Oh, so this time they're not told the velocity or the time. We're told lots of things about where it is. So same setup, same idea, same concept of the problem, just given different factors about it. So start off with ball is projectile. Therefore, sorry, third in a row. Vertical acceleration is 9.80 meters per second down, and horizontal A is 0. And now we get into problem specifics, which is initial velocity is just horizontal. And as it was pointed out in the last one, that means its initial vertical velocity is, if I just have a horizontal velocity, how much am I moving up and down? Nothing. So its initial vertical velocity would be 0. I think that's about all that I need to, that I would need in my Y there. Probably one other factor. Which do you think is going to be more restrictive? The horizontal motion or the vertical motion? Well, let's draw it out and let's see. So I know the ball starts here. It's got to get down to the ground, so it follows this parabolic path. You got, which way do you want to call positive vertically? Which way? Up, okay. Which way do you want to call positive horizontally? To the right? Okay. Vertically, what do you want to call the position the ball starts at? 0? That would mean it lands at, for me, 51 centimeters. So this, for me, vertically, this is going to be at negative, let's see, let me look quickly. You want the answer in meters per second. I'm going to convert that centimeters to meters, so negative 0.51 meters. Now, horizontally, what do you want to call the point that it begins at? Horizontally. 0 meters? Good. Okay. And that means horizontally it ends up at 12 meters. So this is 12 meters horizontally. And I know my initial velocity is in that direction. We'll just call that V. I don't know what it is. Because you told me up was positive and that the ball started at a height of 0. So it lands, it told me 51 centimeters below that. So I'd indicate that direction by negative, and I converted my 51 centimeters to meters. We are doing 6. We are doing, sir? All right, so in looking at this, I know more about the vertical side. I know it starts at 0, it ends up at negative 0.51 meters. Its initial velocity is 0. Horizontally, I know where it starts and ends, but I don't know what that initial velocity is. So my gut is telling me that the vertical, because I know more about it, is going to more be restrictive on time. It could move out horizontally forever, but vertically, if it's starting at 0, it only has so much time to get down to that negative 0.51 meters. So my thought, and I might even put this in my y, is that the vertical dimension is controlling or restricting the time. And all that does, that gives me an idea, which side should I start on? So that means I'm going to start on my vertical side, which is over here, and then I will go over to my horizontal side. But let me get down the facts that I know. Let's see. Horizontally, its velocity is v. Acceleration is 0 meters per second per second. Its initial position, g0, is 0 meters. It ends up at 12 meters. That's all I know. Vertically here, my initial velocity is 0 meters per second. My final velocity, no clue. But I know my acceleration is downwards, negative 9.80 meters per second per second. d0, you told me, was 0 meters. My d is negative 0.51 meters. So I've got down all my factoids. Now I look at it and say, okay, I'm going to start on the vertical side because that's the one I think is more restrictive. And I want to see if I can find out the amount of time, because it's asking me for what was the initial speed of the tennis ball. Well, the initial speed of my tennis ball is over on my horizontal side. If I can find the time, maybe I can find that, do some more work on the horizontal, otherwise I feel like I'm stuck right now. So I'm going to start on the vertical side to hopefully find the time, and then go over and work on the horizontal side. So vertically, I'm going to use d equals d0 plus v initial t plus 1/2 at squared, because I don't know like what velocity I end up at or the amount of time, but I do know acceleration, I do know initial velocity, I do know final distance, final position. So it seems like I know a lot more in this than I would in my other ones. My d0 is 0, so I just get rid of that. My v initial is 0, so that gets rid of that term. Oh, nice. My d is negative 0.51 meters. That equals 1/2 times negative 9.80 meters per second t squared. Oh, nice. Only variable I have in there is t. So I can do a little rearranging, right, algebraically, get the t by itself. So if I bring this over here, I get negative 0.51 meters over 1/2 times negative 9.80 meters per second equals t squared. Do that and solve for t. Oh, good. My negative will cancel out my negative, so I don't end up with imaginary time. It could be kind of a problem. I end up with a time of 0.3226168512 seconds. And that is the time for both sides. So that can come right up there. And then I can use that on either side. So We good on getting that time? Yeah, okay. So now horizontally, I want to know what V is. Oh, I'm going to use the same equation. Why? Because it's the only one that doesn't involve the velocity changing as its prime objective. And since my velocity doesn't change horizontally, it's the only one I can use horizontally. This acceleration is always 0 here. So I said my d naught was 0, so that's gone also. So I'm left with 12 meters equals v times my time, which is 0.32261685112 seconds. And so my v equals 37.2 meters per second. Let's see if that's right. All right, we might as well do number 9. 8 and 9 rats for about the same amount, so I already did 8 last block, so I feel like doing 9. Again, same kind of starting point, right? Number 9, the pumpkin is a projectile. Therefore, vertical acceleration is 9.80 meters per second squared down. And horizontal acceleration is 0. Some things to note, some things to notice about this problem in specific is that it lands at the same height that it took off at. So lands same height as start. What about its initial velocity? It doesn't tell us that though. Oh, you're thinking of 8. You're looking at 8. We're looking at 9. 8 is the football, 9 is the pumpkin, right? It's asking for the minimum initial speed of the pumpkin. Well, for the minimum initial speed of the pumpkin to go this far, that would mean it would have to be at a maximum horizontal distance, right? That's the other way to think about it. Either think, what's the lowest speed I could launch that at to get there, or that's the furthest I could get it at this speed. And to get it to that position, you have to launch it at the perfect angle, and the perfect angle to get maximum horizontal distance is 45 degrees. We played with that a little bit at the end of the last discussion. Right. Or in your projectile challenge coming up, if you wanted to maximize your range, it'd be at 45 degrees. Yeah, so how would I put that in here? I'd probably put to max horizontal distance, and that's sometimes called range. Launch at 45 degrees to horizontal. So I'm going to launch this pumpkin that's going to be a projectile at 45 degrees so I can get its maximum range. And by getting the maximum range, I'm getting the minimum velocity it's launched at. So what that's going to look like if I draw it out If the pumpkin's going to follow this path like this, remember I know it's accelerating because that's curved. If I look just at this little part here, that little part has a velocity heading in this direction, and that's at 45 degrees to the horizontal. All right? Just that little part. As soon as it starts going up, that velocity starts flattening out. All right? I'm going to assume at this point you guys want to call up positive and to the right positive. Yes? Is that okay? Let's call this a height of 0 meters. We'll call this horizontally. We'll say this point's at 0 meters also. And then this point for me is at 3,900 feet. It's a nasty unit. 3,900 feet. I don't like that. So right away, I'm going to convert that to meters. And let's see, so I'm going to use my calculator to convert it because I go to apps and I go to side tools. And in side tools, they have a unit converter. I could also do it, there's about 20 apps you can download on your phone to do it, or there's ones on the computer. You should have that. If not, hook up to a computer and download side tools. Side tools, it's called. And then unit converter. You can use mine afterwards if you want. Putting in 3,900. What's what? Any key. A key. And I get, see, that's times 10 to the third, so 1.8 9 meters. I use the Side Tools apps in my calculator, or just download any app from the internet onto your phone. Yes, you put in the number now, and then arrow over to feet, hit enter, and then arrow to meters and hit enter. I wish I could show you, but they still are. I'm still waiting on it up here. Feet is FT. Yes, FM would be Fermi's. You put in the number, you arrow over till FT is highlighted, hit enter, arrow over till M is highlighted for meters, hit enter. Notice that it's in scientific notation, so be careful of that. That's the most common mistake, is that it's in scientific notation. I took mine out of scientific notation. I have about 4 that I use for track that are all free. So try changing your thing to your top choice filter to free. I'm really worried because we have like 2 minutes. I want to at least get one more step here done. I can go over scientific notation with you some other time. Okay. I need to eventually get this into my horizontal and vertical. To do that, this initial velocity is in both directions. I need to break that up into horizontal and vertical. So what I'm going to do is take that initial velocity like this, and I'm going to say, what's its horizontal, what's its vertical? And I just messed up the colors on those, so I'm going to redo those. So horizontally, what's the component of it horizontally? What's the component of it vertically? Well, I know that this angle in here is 45 degrees. That means this side, the horizontal side, is B times cosine 45 degrees. And the red side is V sine 45 degrees. So then I can do things, bring it down into horizontal and vertical separate. This one is up online a couple of times. All right, 8 is almost identical to it, except in 8 you're given different information, but it's the same problem. All right.